Okay, hello everyone, and welcome to the tutorial video on the AOLE project. This is a project within the Auto Factory of the Future. Um, it was conducted by me, Duc Pham, and it was supervised by Udayanto Atmojo. So on the screen here, as you can see, this is the Git I created to store all of the necessary file, as you can see here. And also I created like a README to walk you through all of the descriptions, installation, how to use. So this video will serve as a better demonstration on how you can use the part, the necessary software, and how the outcome should look like. Okay, so first of all, I would recommend you to read the report I have written here to get a better overview of how the architecture is. I also included a picture here, and the foundation behind it. But this video is strictly practical, and it was only me trying to um, guide you through all of the necessary components of this project. So first of all, one of the core thing about this project is visual components. Um, so in order to have this project going, you have to install all of the software necessary, which I listed in the Git already. But here I have the premium version of Visual Components. So you can use the free version or the demo version, I think, but it has to have this connectivity tab where it can connect to other software with standard OPC UA communication. So I have already uploaded the file. It name layout. You can find it in the Git. So the first thing you need to do is to open um, this file to see. So here I created a little like a miniature of a production line. Uh, okay, so this is the layout of it. So over here first you will need to start the server. Here you can see like there's an add-on panel here where you can start the server. So you see the message here. It's hosted on OPC UA server on Visual Components, and from that you can use UA Expert or any other OPC UA clients to try and connect to it. So it can detect it here. So you see it successfully hosted, and I can connect to it. And with these, you can actually see all of the components, all of the criteria, how it looks like, what's in there, and also when you drag one here, you can get all of the necessary information of the components. For example, here, status is good. So basically over here, it's just a set of values. All of this criteria is linked to the sensor conveyor. So you can kind of modify it remotely from here also. For example, you can modify the dimensions, all of the others signals are there, so you can kind of play along with it. So I will let you to explore it, but what you would need to do is to explore the server over here. If it's not here, then you will need to add it manually, so you can have this edit URL. I also posted like the server address name over there, so you can just copy paste it in here. It will show this one. So I believe that all of these certificates has expired in some ways. So you can just go with the none options, and it should let you connect it to the layout we have over here. So whatever you put into the layout, it will update it in UI Expert. All you have to do is to right click over here and rebrowse, and keep it updated. So yeah, so it would come to the second thing. You will need to install a software which serves as an OPC client. So over here, we'll walk you through a bit. So this layout, I kind of try to create the most complete production line as I could. So over here, you have um, heavy machineries, robot arms. Um, you have a feeder which will feed in the raw materials. Over here, you will have human workers. Uh, you also will have an AGV with a robot arm on it, with automatically doing the transportation. And over here, I have a little, you know, I would call this a quality control section, where it checks the quality of the products over here. And then this is the boxing stations. So this layout is it's opened, and you can actually further develop it, put in more components. But just to remind you that this is quite heavy, so you will rather have a strong computer to do it. So here you have the simulations. Um, I will start and walk you through the simulation later. So all of the things are connected. So I would like to launch everything first. Um, so that's the visual components. What is next? Okay, the next thing is TwinCAD software. So this will be the middleware to connect from the simulation to the real automation settings. And then this is also the means to connect it to the cloud service. So over here, you would need to open this file, IoT MQTT sample using Q. Um, I also included in Git in the TwinCat folder. Take some time. So as you can see, I have quite many heavy software running in the background, so it's a bit lag. I will come back after it finish loading. Okay, so I'm back. Um, Over here, I will walk you through the code a bit to understand what are the criteria that you need to modify in order to make it to work. Um, so here there are a couple of things. So first of all, this will be connected to ThingSpeak. So over here you have the ThingSpeak line. So first we need to go to ThingSpeak. So first of all, I will have to log in. This is very handy because it's linked to MATLAB. So if you already have an account, you can just log into it. It's completely free and it's very fast to register. So over here, I have already created a channel for the purpose of this project. In the README file, I also have included like a link where you can follow, so you can know how can I create such a channel. So over here, you have to press on the channel. You will have to go to the API keys. So over here, there are some fields. You can add more to it. So we'll come back to that later. But the API keys are very important. You go here, you can see the right API key register here. So what you have to do, you have to copy this key, and you have to replace it in here. So it will know which channel uh, it's supposed to publish the data. So over here, so that's all you need to care about for the ThinkSpeak connection. So over here, it's your own computer. So here it's the IP address. So how can you find your IP address? You can go to command prompts. So this is my command prompt. You can go to ipconfig. So it will list it your IP address over here. So last time I was connected to my phone hotspot, so it changes now. I will have to change it back. It's 50, 85. So we need to save that. So the port, I kind of leave the port on its own. Yeah, so just leave the port as it is. Over here, it's as something else. So here, this is also where it would publish the data. So remember, put the field, the correct field you want it to be. So for here, you can see, for example, here I created two fields of data, and I wanted to publish to field one over here. But for example, for the purpose of this tutorial, I would like to publish it to field number 2. Change it to field number 2, save it to. Yeah, so that's all. Also, another important thing about this, it's this references over here. You can see a lot of this TC. So these TCs are libraries, and these libraries are needed in order to for you to successfully establish a connection. So if your file is missing any of this library, you can manually add it here by right click on the references, and you can add library, and you can over there you can find these names I got here and just add it in. So another thing that is the main part. So this is the main, you just keep it the way it is. So over here I declare two extra variables, part at sensor and part count. This will be connected to uh, visual components to get the data. So I will walk you through a bit. So over here, part at sensor and part at sensor. Over here I will show you. So I think that's it for now. So let's start establishing the connections between these software. So first you already hosted, but here you can. So visual components not only can host it an OpenSea UA server, it can also serve as an OpenSea client. So over here I can connect to TwinCAD through OpenSea UA. So first of all, I will have to start TwinCAD first. I will press on activate configuration. Okay. Take some time. You can see here it's writing file import, so this is quite heavy. Patient. So usually it didn't take this long. So I guess this also because of this screen recording software I'm running, it makes everything a bit slow. So I will pause here and I will come back to you after it finished loading. Okay, so it finished loading. It will prompt to you to this box. Just press OK. So it says you're ready. Right. So you would know that it's ready to run when this green login button here, and then you can just log in. So it asks this, just say yes. Okay, so we are in. You can just press run. Okay, so it established necessary connection. So the next start you will need to run is Mosquito. I have already show you in the installation guide how to install Mosquito. So now I will run it for you. So in order to run Mosquito, you will need to open command prompt. Okay, over here, command prompt. Then you would need to direct yourself to the Mosquito installation folder. So over here I have a path. You can just direct yourself there, and then you can uh, run it. All of this guide uh, it's in the installation guide already. I have posted with, so you can just follow my guidelines there. But over here, run it for you so you can see how it should go. Okay, so the moment you see this, this is the connection established successfully. So you can see it also turned true over here. Here, MQTT client be connected true. That's when you know that it successfully connected TwinCAD to ThinkSpeak. So now you will need to connect TwinCAD to backoff. So you can just press on the server. You can here I already configure it, but If you are doing it first time, you can't. So usually for TwinCAT, it automatically detect it. You can just test on the connection. You see it's success, connection succeeded. So you just apply, and then you press on this button. It will go live. So over here, you can see the connected variables. So I have already connected the necessary variables to, but you can do it by right click on this and you can add variables. So simulation to server, you will need to link the corresponding um, variables here to the corresponding variables in TwinCAT. So here you can see select signals. So I have a sensor conveyor. Um, so I would link whenever it detects a piece, it will put the counter uh, to 1. So parted sensor, you can just pair it. You see here I already pair it, so I don't pair it again. Parted sensor. And on the other way around, you would need to, if you want to send back any of the commands, for example, when it detects a part, then it will stop the conveyor or something, then you will do it on this reverse direction. But I didn't put any, so you can just try to do it yourself. So it's connected here. So I think this is a good time for me to walk you through the simulation. So over here, it will start from this point where it got like a simple cylinder shape raw material. I will speed it up a bit. And then this robot hand will install this raw material into this machine right here, where I think it will here. It will turn the raw material into shape. So here I have like a piston. So this machine, you can consider it to be like a CNC machine or a lathe machine, which put part into shape. And over here I have 2 smaller machines, which will paint the piece. So you see here the piece was painted green, and over here in this machine it will be painted red. So I will speed it up a bit. So you see here the finished product will be put to this cylinder over here and transported to the next phase, the assembly phase. So here over here I put like a worker with manual work to do this job, but you can play around, try to replace it with a robot or something. But over here he will take this piece, he will have like already made another piece over there, and he will connect these 2 pieces together, and he move it to the next phase, the transportation phase, where this HEV will pick it up with its robot arm here, you see, and it will go over here to the quality check um, area, where it will check if this product is actually the right product. So you see it check for the ID. Here's 123. So it's correct. And then this is the boxing station, where this robot arm will automatically put product into boxes. And this will go to transportation. So every time a workpiece go through here successfully, it will send a signal to TwinCAD. So over here, you see this is a signal. So it counted for like 2 part here. and now it comes to three part. So this number will be sent to ThinkSpeak to cloud, which I have helped you to establish the the connection over here. So you see it. So remember, I put it into field 2 chart, not field 1 anymore. So here you can see the counter is updated over here. So you can imagine ThinkSpeak as MES or the, the controller of enterprise, where the production data will feed directly to um, like the planning department or something. Um, so they can adjust in real time. So everything is running in real time, even though this is just a simulation. Um, yes, so that is it. It will keep running until you stop the simulation, and this connection will keep going. Yeah, so stop this so it won't be too lag anymore. So yeah, that is all. Um, I will have I just have just walked you through how it should work in this project, and but you will still have to do the installation yourself. So this project, I will talk to you a bit about the architecture over here. So the purpose of this project is to actually try to remote control of automation related settings, for example, manufacturing or logistic, and you kind of have the power to actually modify these the simulations, um, and also you can kind of validate new ideas through these simulations to see how it communicates from different layers of the enterprise. So I assume you know the automation pyramid. So from the top level to the ground level. So over here it offers communication from the ground level to the top level, and you can actually modify it along the way. So over here we kind of trying to make it possible to do it entirely remote, um, because of trying to improve the efficiency of, of current factories. Also, it kind of serve as a very good learning tools for students who are trying to step foot inside of the automation industry, industrial automation industry. And also this can be developed industrially also, I think. So this is a very good validation tools, so you can actually test the efficiency. As you can see here, I can test like how many products can the production line produce per hour, and you can kind of trying to make modification modification along the way to see if you can actually increase this efficiency. For example, that's one scenario I can think of. Another scenario is that you want to train your new employees, or you can't, or you want to actually update your senior engineer with the new production line. For example, you have just assembled. So to me, this project has a huge potential, and there are still a lot of work has to be done. For example, over here, I still have this OPC server, um, on hold that I'm trying to implement, that you can actually send command, and then it will modify the simulations directly. For example, here I have a little bit of demo. I haven't like implemented fully, but over here you can see, for example, I can put like add variables, and then it will prompt me to this is blank, but it can ask me like to choose which components, and then it automatically add it here. So instead of you just manually actually have to connect things, it will help you to connect things through a set of APIs I created, and you can access all of them remotely. So here also very good example. So if you press on the cell graph up here, it will actually display all the list of the components are there in the simulation, and you can just press on it and it will just bring you to the part itself. For example, I want to access this conveyor, just double click on it and it will zoom into that component. As you can see here, or you can do it with OPC UA client I have. So I think that is all for this tutorial video. I would like to take this opportunity to thank Udayanto for creating such an amazing problems for me to solve, and um, I hope whoever will continue this project, or maybe me, best of luck. And yeah, I would like to see this to develop more to its potential. Thank you for watching.